Hello everybody, it's Tuesday the 2nd of March and this is your maths lesson for today, and we're going to carry on with our adding fractions, and we're looking at adding fractions that will go into improper fractions and mixed numbers. To begin with, you've got your 4 a day to have a go at, so choose your colours. If you're having a go at the green ones today, you've got these addition pyramids, and like yesterday's, the 2 bricks on the wall at the bottom when added together give you the one above. So how would you find out these missing 4 bricks in the wall? Have a go at your 4 a day and then your answers will come after. Here are your answers for your 4 a day. Have a look and see how you did, and then we'll get moving on our lesson today. We'll begin with our get ready questions. 3 questions today for you to try. Have a go. Pause the video. Have a go at these, and again have a think before you do. What things can you write down to help you? Let's have a look and see. Question number 1, we have a part-whole model. So we have a half, a quarter and a half, and when added together, what total does that give? And we can see we have a half and a half, and if we add those together we get 1 whole, and that leaves us with our quarter, so our answer would be 1 whole and a quarter. Question number 2, we have 5/7, 4 21s and 3/7, and when we add them together, what would our total be? But what we should have done in order to answer that question is we had to convert our 7ths to 21s, and we would have times those fractions by 3, because 7 times 3 is 21. 5/7 is equal to 15 21s, and 3/7 is equal to 9 21s. Now that we've done that, we can add them together, giving us a total of 28 21s, which is the same as 1 whole and 7 21s. And can you think, what is 7 21s the same as? If you know your 7 times table, you know that 3 times 7 is 21, and that's the same as 1/3. And for question number 3, 1/5 is equal to something 15ths. We have our denominator, but we don't have our numerator. So what would we have had to have done to convert 5 to 15? We would have had to have times by 3. And whatever we do to the bottom, we do the same to the top. So 1/5 is the same as 3/15. And again, we can see the numerator has changed to 9. And to do that, we again times by 3. So we must do the same to the bottom, the denominator. So what is 15 times 3? So we have 1/5 is equal to 3/15, which is equal to 9/45. Well done if you managed to do those. Now we're going to get ready with the main part of our lesson. And we're going to start with this question here. We've got 5/6 add 2/3. Just off the top of your head, I'll give you 5 seconds. What would you do to answer this question? Let's see. Well, hopefully we saw that the denominators are not the same, so we would have changed our 2/3 by multiplying by 2 to change them to 4/6. Now we're doing 5/6 add 4/6, and with our fraction bar we already have our 5/6, so we've got to add 4 more sixths on. So we've got to add 1 more sixth. Can we add another sixth like that? The answer would be no, because that would change it to 7ths. So we've actually got 6 sixths, and we would need to take that extra sixth into a new fraction bar. So now we've added 2 of our 4/6, and then we add our 4/6 in total. So now we can see by counting we've got 9/6. That's an improper fraction. What would that be as a mixed number? We can see there this fraction bar is full, it's the whole fraction bar is shaded, so that would be 1 whole, and then we can see underneath we've got 3/6. Have a think, what could you convert 1 whole and 3/6 into? What's equivalent to 3/6? 3/6 is the same as a half. Well done if you managed that one with me. Let's have a look at this problem. I want you to try and do this one by yourself. You've got 3/4, add a half, add 7/8. Pause the video and have a go. How would you answer that one? You can draw some fraction bars to help you if you want to. Pause the video and have a go. Let's have a look and see. The first thing we would have to have done is notice that our denominators are not the same. So which fraction would you have changed the others into? And it would have been this 8ths. So we would have changed our 3/4 by multiplying by 2 to 6/8. We could change our half by multiplying by 4 to 4/8. Then we could have added them together. I've got my 7/8. Then I'm going to add my 6/8. And I would see I used up one of those 6/8 to finish off that fraction bar, and then added my 5 more. Then I've got to add my 4 more 8ths. I've added 3. There's a 4th 8. So how many 8ths are there all together? There are 17/8. That's an improper fraction. What would that be as a mixed number? It would be 2 wholes and 1/8. Have a think now by yourself. You've got these two questions. The first one has a fraction bar we can look at afterwards to help us, but pause the video and have a go at adding these two fraction equations. Have a go at adding them together. When you think you've got your answer, can your answer be simplified? Can you simplify your answer? So that means, can you find an equivalent to that fraction by dividing? Pause the video and have a go. Let's have a look and see. So we had 11/18, add 5/9, and the first thing we should have done was converted by multiplying by 2 our 5/9 to 10/18. We can see there is our 11/18. Now we would add our 10/18, and that would look like that. And we can see there altogether we have got 21/18. What would that be as a mixed number? 1 whole and 3/18. Let's have a look at the second question. We had 11/12, add 10/24, add 5/6. And again, we had to think which of these numbers would we have had to change our denominator to. Now we could have changed them all to 24s. We could have maybe changed them to 12ths by dividing by 2. We could have changed our 10/24 to 5/12. And to do that, we could have changed it and it would have looked like 11/12 and 5/12 and 10/12. Now if you didn't do this way and you changed them to 24th, that's absolutely fine. But the answer, if we changed them to 12ths, was 26/12, or if your answer came to 52/24, that's absolutely fine. But let's look at 26/12. What would that be as a mixed number? It would be 2 wholes, because 12/24 would be in our 12 times table to help us, and then it would be 2 wholes and 2/12. What could we simplify 2/12 into? It would be 1/6. Coming next are some questions for you to try. Again, you need to pause the video, have a go at those questions, and then your answers will follow. Pause the video and have a go at these. Remember to write things down, because it's very important to write things down to help you so you can work out your question and you have all the information you need to help you. Pause the video and have a go. Here are your answers. How did you do? If you wrote things down, then you would have seen that these types of things would have really helped you with your calculating. So changing our half into our tenths and writing those down was very, very important. Well done if you managed to write them down to help you. Here are your answers for you to check. When you've checked them, let's move on to the next question. Have a look at these ones. Now it says complete the additions. Again, what would you do to work these out? And again, can you write your number from an improper fraction to a mixed number? And before you write it down as a mixed number, can you also think, can you simplify your fraction? Can you divide your fraction? Does that number in the fractions, the numerator and the denominator, do they appear in the same times tables? And that's a clue to how you can simplify. Have a go. Here are your answers. Have a look and see how you did. And again, appearing on the screen would have shown you what things you could have written down to help yourself to answer those questions. Did you have a go at simplifying your fractions? If you didn't, don't worry. But again, it's all about your times tables and what you can do to help. Let's have a look at the next one. For this one, it says match the additions that have the same answer. So for this one, you have to write them out and then draw lines matching them. Pause the video and have a go. Here are your answers. And again, what did you do to help you work them out? What did you write down? And again, you hopefully wrote down on the left side, converting your fractions so they had the same denominator to help you. Well done if you managed to answer those correctly. Now we're going to look at a question together, and this is going to use the bar model to help us solve it. Eva has some bottles of lemonade, water and apple juice. The bottles have a mass, which means weight, of 3 kilograms altogether. The bottles of water have a mass of 7/8 of a kilogram in total. Each bottle of lemonade has a mass of 11 kilograms and Eva has 2 bottles of lemonade. How much do all the bottles of apple juice weigh? So have a think. How are you going to solve this problem? What things can you find out you know already? What skill, what method are you going to use that will help you answer this question? Pause the video and have a think first. Where is the important information that you could use in this question? Let's have a look and see. Looking at each sentence, we know that Eva has a bottle of lemonade, water and apple juice. So there are 3 bottles, flavours there. So we're dealing with 3 numbers. The bottles has a mass of 3 kilograms altogether. And altogether it means adding up. So that tells us what type of a question we might have to answer, what skill we will need. The bottles of water have a mass of 7/8 of a kilogram. Each bottle of lemonade has a mass of 11 kilograms. So one bottle has a mass of 11 kilograms, but we know Eva has 2 bottles of lemonade. So we know what the total mass is of all of the bottles. We know how much water weighs. We know how much lemonade weighs. We've got to work out how much apple juice weighs. So let's have a look and see how we could answer it. So let's break the question down again. Eva has some bottles of lemonade, water and apple juice. So we know we have 3 different flavours there. The bottles have a mass of 3 kilograms altogether. So altogether, when you add their weights up, it totals 3 kilograms. The bottles of water have a mass of 7/8 of a kilogram in total. Each bottle of lemonade has a mass of 11 kilograms, and Eva has 2 bottles of lemonade. So that's 2 lots of 11/16 of a kilogram. And the question we need to find is, how much do all the bottles of apple juice weigh? So we need to find out that missing bar. So before we move on, I'm going to give you 20 seconds looking at what's on the screen. What things can we find out? What things can we adapt and change to help us work out this question? I'll give you 20 seconds to have a think. What could we do next? Let's move on and see. Well, first of all, we could maybe look at the 7/8. And 7/8 is the only one that has the denominator of an 8. The other two are 11/16. So the first thing that we could do is change our 7/8 into 16ths. And that would be 14/16. Is there anything else that we could change? We could have also changed the 3 kilograms. We know that 3 kilograms is the total mass of those 3 bottles, and the denominator is 16ths. So what would 3 kilograms be if 1 kilogram was 16th as the denominator? It would be 16/16, 32/16, 48/16. So 3 kilograms is actually 48/16. What can we do now? Now we know that in total 48/16 is what all of the bottles weigh. Can we still find out what this one at the bottom is? What would we do next? What we would need to do is take our 3 calculations, our 3 fractions, and add them together. So that would be 11/16, add 11/16, add 14/16. What would that be? 11 add 11 is 22. 22 add 10 is 32. 32 add 4 is 36/16. So now we know out of the 48/16, the lemonade and the water weigh 36/16. Can we write that in a different way? That's an improper fraction. What would that be as a mixed number? We can see then by taking the 36/16 and counting up to 48/16, the 12/16 is what is left. And that is how much the water would weigh. Sorry, that's how much the apple juice weighs. So well done if you managed to do that, and that was understandable and you coped with that, because there will be a question like that coming up and you'll have to see if you can use your bar models and you're converting your fractions to see if you can work out your answer. Eva has 3 bottles of apple juice. What is the mass of 1 bottle of apple juice? So if she has 3 bottles of apple juice that are 12/16 of a kilogram, what would 1 bottle weigh? I'll give you 10 seconds to have a think. How could you find that out? And the answer is 12/16 is 3 bottles, so 1 bottle would be 12 divided by 3, which is 4/16. What would 4/16 be simplified? It would be 1/4. Well done if you managed to do that one. Now let's have a look at this question. We have 5/8, add 2/7, add 3/8. And the question to ask here is, do we need to change the denominators to the same one? Is there something that we could maybe do different? Have a think. Is there something you notice about those fractions that you've got there? I'll give you 10 seconds to have a look. Let's have a look. If you noticed, if you had your 8ths, your 5/8 and your 3/8 and you added them together, what would you get? You would get 1 whole, 8/8. So now we have 1 whole and 2/7. And that answer is 1 whole and 2/7. So using that skill, how would you answer this question here? You have 4/18, 3/13 and 7/9. What could you do to use that same skill as above, adding 2 fractions that could make a whole? Is that possible? Can you do it? Have a think. Pause the video and have a go. Let's have a look at this question. Which one could we have changed that would have helped us work out this question? If you look carefully, we would have seen we could have done something with the 4/18 and the 7/9. Which one could we have changed? We could have changed 7/9 to 14/18, and then we could have added those together. 4/18 add 14/18 is 18/18, which is the same as 1 whole. And then that would have left us with our 3/13, giving us the answer 1 whole and 3/13. Well done if you managed to do that one. Coming next then are some questions for you to try. Again, you need to pause the video and have a go at these questions, and then your answers will come after. Here we have a word problem. You need to read the question very, very carefully, and like the juice question with the apple juice, the water, you need to see if you can use your bar model to help you. Can you use that to help you out? Break down the question, have a look at the different parts. If you want to, you can go back and look at how we worked out the first question with the bar model method and see if you can use that skill. Look at the information really carefully, and then got 2 questions. It says work out the total weight of the tins of beans, sweet corn and soup. And part B, how much do the tins of tomatoes weigh? Pause the video and have a go at this question. Let's have a look at the question then. It says Dexter has some tins of food. There are 4 types of food: beans, sweet corn, soup and tomatoes. And we can see here are the beans and how much each of them weigh. But what we don't know is how much the tins of tomatoes weigh. What else do we know? We know that the total weight of the tins is 2 kilograms. So how could we have answered this then? What could we have changed? What could we have used to help us? And what we should have seen was that the sweet corn was 5 kilograms. And what we could have done was changed our beans and our soup to match that denominator. And we would have done that by changing our beans from 2/3 to 8/12 and changed our soup from 1/4 to 3/12. Then we had the calculation that we could have worked out. We could have also have seen 2 kilograms is the same as 24/12, and that would have been our total to aim for. So if we did that calculation by doing 8/12 add 5/12 add 3/12 equals 16/12, which is the same as 1 whole and 4/12, or the same as 1 whole and 1/3. So to answer the first question, work out the total weight of the tins of beans, sweet corn and soup. We've done that. We converted the denominators, then we added them together to get 1 whole and 1/3, or 16/12. How would we work out the second question? How much do the tins of tomatoes weigh? So if we know that 24/12 is 2 kilograms of all of the cans, we know 16 of those 12s are the 3 cans we've already got. Then what would we do for the tomatoes? How could we work that out? And what we could have done was subtracted 24 twelfths take away 16 twelfths equals 8 twelfths, which means the same as 2/3. So the tomatoes weighed 2/3 of a kilogram. Now let's look at this question. These are addition pyramids, and we've looked at these before. The two boxes underneath, when added together, give you the total fraction above. So 2/3 add a missing fraction equals 7/6. So again, it's thinking, what skill could you do to work this out? Is it going to be addition? Are you going to need to do the inverse of addition to help you work this out? You don't have fractions with the same denominator, so what things do you need to do? What can you write down to help yourself? Pause the video, have a go at these addition pyramids, and then the answers will come after. Here are your answers. Have a look and see how we did. For the first one, we should have changed them all to sixths, and the same for the second one, and for the third one, we should have changed them all to tenths. If you didn't write 2 wholes, but you wrote 12/6, that's absolutely fine. The same if you didn't write 1 whole and 2/3, you could have written 10/6, 1 whole and 4/6. Well done if you managed to do with those, and well done with those other questions, especially those ones with the bar models were very, very tricky. And that's the end of our lesson for today. And again, if you want to, you can go onto MathsFrame and try those different activities to help you with your skills and understanding. But that's our lesson finished for today. Take care and speak to you tomorrow. Bye bye.